For you today on the methods and mechanisms for successful brewery sanitation. My name is Rudy Othmer. If you got any questions or comments, feel free to enter them in, and I'll keep tabs on that part over there, and then answer them as the time comes. I like to start, even though we call it methods and mechanisms for successful brewery sanitation, I like to start with some real basics on cleaning and sanitizing in general. And we have an acronym that we use, TACT wins, that kind of give us the key points to consider when we are looking at a cleaning system overall. We've got TACT, time, action, chemical concentration, and temperature, wins, the water, the individual, the nature of the soil, and the surface to be cleaned. So we'll spend a little time this morning going through these keys, and then we'll get into some specific applications of how we're going to use these things for different areas in a brewery. So TACT wins is the part to remember. And time, getting a little deeper, it's the contact time on the surface being cleaned. It means a lot more than that, and we'll get into that. Action is how we're doing the cleaning. The chemical and the concentration, that's pretty self-explanatory for what the meaning in the acronym is. Temperature, also pretty self-explanatory. Water, individual, nature of the surface, or nature of the soil, and then the surface. Now it's hard to draw 8 of them on the same little pie chart. But for a complete circle of cleaning, we just put these 4 on here because it's easier. You can vary some within constraints of those 4, these 8, and still get a good cleaning job. But for instance, if we want to take our time for cleaning down, then we're going to have to increase something else out of those 8 in order to have a complete circle still. So for instance, maybe we're going to clean at a higher temperature. We can clean for a shorter amount of time. So the 8 components, the 4 shown here, the 8 altogether, are interactive with each other. None can be taken on its own out of context. You put them together properly. Again, the acronym TACT wins. So getting into time a little bit deeper, it's not just the cleaning time. When we're considering time, we want to look at preparation time for our cleaning, both on the tank or the hoses, the surfaces we're cleaning, our chemical preparation time. Are they automatically pumped out of drums, or do we need to measure by hand, so on and so forth? Then the actual cleaning time, and that divides into several components, reassembly of components, and also the time between cleanings. So if you're looking at your SOP and you say, okay, well, I'm gonna cycle my acid for 15 minutes, and we all know that's good, but that is not going to take you 15 minutes. You've got filling time with your water. You've got mixing time to get your acid CIP in there, and then the 15 minutes begins. So time is an important component in thinking about and designing a full system for cleaning. Action, there's several different ways in which we clean. There's several different actions. We do manual cleaning when appropriate or when necessary. Brushes, scrubbies. We're in there working on the foam ring, hopefully with a scrubby that does not scratch our stainless steel. Foam cleaning is an appropriate action where we're generating foam that clings. Pressure cleaning, similar to foam, but we're using the high pressure of the cleaning solution impacting the surface to do part of the cleaning. Spray cleaning, lower pressure, doesn't bounce off as much, but you can get the right soil penetration. And then mostly in the brewery, the parts that we're most interested in, at least CIP, clean in place, where we generate a small volume of cleaning solution and pump it around, spray it inside of our vessels, and it pumps through our hoses and so on and so forth. And then there's COP also, cleaning out of place. And we use that in the brewery, as you guys know, for fittings and hoses and screens, that sort of thing. So coming down to the C in TACT, we got our chemical, our concentration, and we'll spend a little bit of extra time considering our chemical concentration. We divide our chemicals into three major groups: the alkaline cleaners, the acidic cleaners, and the sanitizers. And I make a special note for everybody because when you think back on that circle, you think, oh, I want to save time. I want to lower my temperatures. I want to do things really easy. So I'm going to maximize the amount of chemical that I'm going to use. That's not the way to go. You want to have the proper amount of chemical in your solution. You don't want to necessarily have the maximum amount. And when we get into the winds, when we start looking at the water, we'll see why the maximum amount of chemical is not necessarily the best, in that the water in the solution plays a very important role. Our alkaline cleaners, in general, used for removal of organic soils. So we're thinking about our oils, residue from the hops, so on and so forth. All the things that were once living that are now hanging out inside of our tank and that we need to remove, we do so with an alkaline cleaner. The alkalinity, either sodium hydroxide or potassium hydroxide, typically for a high alkaline cleaner, generally combined with surfactants, and that's an abbreviation that's short for surface active agent. So the surfactant in the chemical blend acts to help the working ingredient, the sodium hydroxide or potassium hydroxide, in contacting the soil. Depending on our action, if we are trying to make foam, there may be a foam additive in the cleaner. If we're trying to CIP and reduce foam, there's probably going to be some anti-foam agents added into the cleaner. And when you're looking at cleaning in general, again, clean off your organic soils first. Use an alkaline cleaner first, and then move on to an acidic cleaner. The acid cleaners designed and very good at removing your inorganic soils, minerals, hard water deposits, all the stuff that was not carbon-based, was not alive at some point in time. Calcium and magnesium, silica, those sorts of things. Again, just as the alkaline cleaners had surfactants added to them, your acid cleaners will have surfactants, or can have surfactants as well. And they'll have the foaming and the anti-foaming agents in addition. Specifically, when we're looking at a brewery cleaning system, the other reason we use the acidic cleaners second, well, I guess I didn't mention the first reason that we use the acidic cleaner second is the acids can tend to burn the organic soils onto the surface as opposed to cleaning them away, which makes them extremely difficult to later remove. So we want to remove all our organics first, and then come in with an acid for taking off the minerals. The second reason, and not as big of a reason for our brewery folks, is the acidic cleaners also neutralize any residue left over from our alkaline cleaning process. Our 304 stainless steel in general, very much desires to be in an acid state. Our good passivation level, or our good passivation layer on our stainless is preserved by keeping it slightly acidic. And it's in addition to its ease of cleaning and so on and so forth. Stainless is chosen in the brewery industry because our beers are largely acidic and they play very, very well together with the stainless. So our third category after our alkaline cleaners and our acid cleaners are our sanitizers. Now our cleaning products, our alkaline cleaners, our acid cleaners, we rinse after those steps, and we rinse with water. The differentiation with the sanitizer is they are all going to be EPA registered, and they're all going to be for part of a sanitizer is you don't rinse afterwards. No rinsing necessary. Being EPA registered, they have had to have proven their efficacy at reducing our bacteria in our living organisms to a safe level. Now, they don't get them all the way to zero. There's not a reduction totally to nothing, but they're effective for reducing to a safe level. Because they have been tested and pedigreed and registered EPA, you will always find a statement that says it's a violation of federal law to use this product in a manner inconsistent with its labeling. So the sanitizers in particular, extremely important to read the label for your specific application and follow the concentration required on that label, as well as the contact time and any other specifics. So you don't want to use your sanitizers willy-nilly. You want to use them according to the label, always, always, always. There's many different active ingredients that make up sanitizers. Probably are all familiar with chlorine and iodophores. The iodophores in particular, good for our 3-sink systems, our dishwashing, a final exposure on glassware, so on and so forth. Hydrogen peroxide, we find as a blend frequently in our main brewery sanitizer. Quats, small breweries, we don't see quats very much at all. Larger breweries, they'll use quats for area sanitation. You don't want to ever use a quat on any beer contact surface because it is unrinsed. There's a little bit of residual left over, and the quat has a characteristic of killing the head on the beer. So that's an undesirable side effect. So quats only on non-beer contact surfaces for that reason. Not because it's not labeled that way. It's just because it's a tidbit to keep in mind. And then probably the most popular in breweries is the acid sanitizers. The peracetic acid, hydrogen peroxide blends, or just peracetic acid on its own. And one of the reasons for that is the low pH of the product tends to keep our passivation layer on our stainless intact. So that was our C in TACT. Our right temperature. Again, just as we don't necessarily want to maximize our chemical concentration, we don't necessarily need to maximize our temperature. We need to clean at the right temperature. That having been said, on a molecular level, and when we talk about cleaning, we're talking about a single molecule of our cleaner contacting a molecule of soil and pulling it off of the surface, putting it in the water so it can be rinsed away. Our molecular activity doubles approximately for every 10 degrees increase in Fahrenheit in temperature. So at 130 degrees Fahrenheit, we'll have half as many molecular collisions as we will at 140 degrees Fahrenheit, so on and so forth. So temperature is extremely important. If we can get higher, we're generally better off. But for instance, maybe surfaces that we have in our overall cleaning system, hoses, gaskets, etc., won't allow us to get to the highest temperature. Maybe we would like to preserve or not have to recool a tank. And so if we can cool that at a lower temperature, it saves us somewhere else in the overall process. So there again is why all of these items are linked together. Water, the W in wins. We use water, the universal solvent, to pre-rinse. It also softens and wets the soil on the surface. We use it to carry the cleaner to the surface, and again to carry the soluble wastes away from the surface on a molecular level. It also is used to rinse unused cleaner off of the surface. And so it's important in the design of your cleaning system to get your chemical water ratio what it needs to be. Now, all these wonderful characteristics of water and its very good usefulness comes with several big problems. When we say water, we're typically talking about water plus all of the impurities that it's already dissolved in it, that it has carrying with it from our city or from our well, whatever our source is. Water's got one other characteristic that is both good and bad we'll get to in a minute. But in terms of the most serious impurities that we typically encounter is hardness, our calcium and magnesium that's dissolved in the water. It leaves the white staining, it leaves the hard water deposits. It can interact with our alkaline cleaning and interfere with its doing its job. And if you're in an area with high iron, it can cause rust stains inside of your stainless and give you extra item to deal with. Depending on the level of calcium that you have, it can be removed with a water softener before it even gets to your before it even gets into the before you even start your cleaning process. However, the calcium, the impurities that come with your water are actually beneficial in your brew. And so you have to balance your cleaning procedure, the chemicals that you're using, with any pre-treatment that you do. Typically, it's going to be the same water on both sides. And again, there's many things that can be added to your cleaning, to your cleaners, and that should be added from your supplier right in the formula to deal with the impurities that you're encountering specific at your location. Water also has a very high surface tension. And that's the attraction, the interaction between the individual water molecules. Unfortunately, the surface tension for us prevents, to a large extent, the water from, on a molecular level again, getting to the dirt that we're trying to have it remove. And so that's where our surfactants come in as part of our cleaning system. So who's doing the cleaning? You want to, if you're the one doing the cleaning, you want to know yourself. If you've got someone else doing the cleaning, you want to know them. Are you a very precise individual that will every time measure out how much water you've got in your tank and measure out to the nearest ml how much cleaner you're going to add into there? You can probably do it by hand. If you've got 16 people all with their fingers in the pie, you want to look at some controls for dosing and getting the right amount. So know who is doing the work and what their personality is like and what they are naturally inclined toward. If you're naturally inclined to put tasks off, then recognize that about yourself, and to the extent you can, schedule production in such a way that when it gets time to clean, you aren't tired and you're thinking, oh, it's time to go home, I'll just do it tomorrow. Because it's going to be a whole lot easier if you take the time to run through your cleaning procedure while the tank is still wet and the soils are fresh. So understand yourself. And we've kind of talked a lot about it in the previous steps already, but know the nature of what you're trying to remove. Organic or inorganic? Is it baked on? Is it hard, or is it loosely adhering? Is it a combination of that and it requires multiple steps? Just as important as picking the chemical, just as important as the temperature, maybe more so in some cases, is knowing what it is that you're trying to remove. And then lastly, the S in WINS is the surface. Does our system consist exclusively of stainless steel? Or do we have soft metals present? A heat exchanger, for instance, or some piping that didn't get done right that's going to be part of our CIP system. Also, what kind of gaskets, what kind of rubber do we have on our fittings? Are we using flexible hoses that's a unit N or an EPDM? So know your materials of construction for the whole system, not just for part of it. Look all the way through. What's the impeller on your circulation pump made of? You want to make sure if it's in contact with your cleaning solution that those are going to be compatible with each other so that you avoid damaging any of your surfaces. A couple ways that you can damage things. Stainless steel can be damaged by high chlorides, either in a product where you've got a product that they picked the wrong acid for the application, or if you're using a halogen-based hypochlorite bleach sanitizer, you can damage your stainless steel surface. If you're brewing in copper, that qualifies as a soft metal. The copper can be attacked both by high alkaline and acidic products. So you may have to lower your temperature down. You may have to reduce your cleaning time or your concentration to preserve that copper kettle. And then the rubber and plastics, primarily looking at compatibility with components in the sanitizers. So TACT WINS: time, action, chemical, temperature, the water, individual doing the cleaning, the nature of the soil, and the surface. So we got to put those all together into a cleaning system for each part of, in this case, for each part of our brewery. So what parts need to be cleaned, what types of soils exist, and what are the special situations where you might run into trouble. So let's run through each of these parts in a typical brewery and take a look at things. Again, looking at kind of a high level view of it, if you will. So our parts of a brewery to clean. When you're first setting up setting up your brewery, you've got probably some new stainless steel vessels. Ongoing, of course, we got a hot liquor tank where we're maintaining, creating and maintaining some hot water for various uses. We've got our brew house tanks, including lines and potentially heat exchangers, and then storage tanks, fermenters, etc. Hoses and fittings, the little pieces, parts. We want to make sure we keep our tank exteriors clean and sanitary, not only because we want the folks that are eating or drinking at the bar and looking through the window to enjoy what they're seeing, but also from the standpoint of GMP. Floors and walls, again, and then we don't want to forget about our drains. So I stressed it pretty good earlier, but be the right person to do the job. If you're the one doing it, be the right one for it. Think about what you're doing, particularly the alkaline cleaners and the acid cleaners, and even the peracetic acid sanitizers that you guys are using can be dangerous to use. So respect them. I grew up fortunate enough to have my grandfather around, and his philosophy was, you have one set of eyes, and they need to last you for your entire life. So don't do something sloppy, don't do something quick and dirty today that you're going to try, that has the possibility of sacrificing your eyesight. Think about what you're doing, respect the chemicals. Don't be, if you're an individual that is shaky and nervous around them and scared, then, are there other possibilities for you? Is there somebody that can help you, or is there someone else that can do the job until you get the comfort level that's needed? Inspect your equipment. Don't just wonder what the deposit might be. Figure out what it is. Don't just go through the procedure and wonder whether it worked. Take a look and figure it out. Now, you get your tank interior clean, you don't want to touch it, because where you touched it, it used to be clean. It now has a fingerprint on it, unless you had clean gloves on. So one of my other mantras is, if you can't measure it, you can't manage it. In the inspection part, both on how dirty the tank is and what is in it, and that's going to vary depending on what you're brewing. And don't assume that your cleaning procedure worked. Take the time to do the inspection. So we're first setting up our brewery. We got some new stainless steel vessels. We need to remove dirt, dust, shipping compounds. We need to get the vessel clean first. Typically going to be done with an alkaline CIP. Sometimes, depending on where the tank came from, some manufacturers passivate themselves and ship you a quote unquote clean tank. You want to clean it and passivate it for yourself anyway once it's installed. Some have thick, greasy shipping compounds on them, and your regular everyday alkaline CIP product may not be enough. You may need product with a higher amount of solvent character in it to remove your shipping compounds. Second step on your new stainless is make sure that the surface is well passivated before you use it. That's going to assure that your capital equipment is going to last you as long as you would like it to, as long as it should last. One note on passivation is the stainless has to be clean before you passivate. You don't want to have any shipping compound left on there. You don't want to have any dirt, any specks. All of those things are going to interfere with creation of that passive layer. And I don't have a slide on it. I don't believe, no, I don't have a slide on it, but you can use what's called the water break test. If you're wondering whether your stainless surface is clean, and that is allow water to run down the vertical surface on the tank and observe its behavior. If the water runs down and it's a perfect sheet, then your stainless is likely very, very clean. If the water runs down and it looks like a river that has stones in it, and the water is breaking over those and creating little V's, then you've got cleaning yet to do before you begin your passivation process. So our hot liquor tank, again, we're creating and storing hot water in there. That water probably has a level of hardness in it. As we heat the water, we're going to create scale with that hardness. Basically in the hot liquor tank, because we're not doing anything else, all we need to do is periodically descale, as well as make sure we're maintaining our passive layer. So we're going to use an acid descaler in our hot liquor tank as needed. When either we're not heating as fast as we need to, or we look in there and observe that off-white yellowish layer developing on our heat exchanger. So brew house tanks, we're going to have various amounts and kinds of organic deposits on the tank, in the tank, holes stuck in our false bottoms, etc. Also can frequently have inorganic soils form in the brew house tanks because of our temperature, and maybe because of calcium or phosphate additions depending on our brew. Again, we want to preserve our stainless steel. And here, because we are starting our process and we've got a food contact surface, we need to assure that our microorganisms are maintained below safe levels. Because that tank is typically pretty big, and we're not going to pick it up and put it in a sink and clean it out of place, and nobody's going to crawl inside and manually clean. Although sometimes some scrubbies, again, are needed, but normally you're going to clean that tank in place. Again, you want to keep it wet until it's ready to clean. Never let those barley hulls dry on. Never let the foam ring at the top get stuck on by drying. We're going to want to rinse everything out that we can rinse out. And then typically our alkaline caustic cycle and rinse. Here again, normally that caustic cycle is fairly long, 30 to 40 minutes. Here we've got the capability of running above our 140 degrees. So we'd like to do that at 170, 180 degrees. Because it speeds the process, does a more thorough job. And then an acid cycle, followed by, again, the rinse and then sanitize. And if you're observing you don't have a lot of inorganic materials built up, and your caustic cycle worked really well for the organics, and you rinsed thoroughly, you can sometimes skip that acid cycle, especially if you're using an acid sanitizer. Because again, we want when we're finished with our cleaning process, we'd like that stainless steel, the last thing it had experienced, to be low pH. So our storage tanks, we're using these a lot. Not as hard, if you will, in terms of the organic soils that are going to accumulate on there. Mostly lightly adhering, a little bit of residue left over. Almost all organic, very little inorganic, at least very little inorganic that is stuck on the tanks, because they're low temperature. We're not actually doing any boiling per se there. But again, we need to preserve the stainless steel or preserve the materials of construction and make sure our microorganisms are at a safe level. So again, they're big tanks, so we're going to CIP them. You'll notice a lot of repeats here. Keep it wet until it's clean. Because our organics are lightly adhering, in the last, about 5 or 6 years ago, there have become available in the market some acid detergents that are extremely effective at organic soils. They won't do a thing for you in the brew house, but you can skip the alkaline CIP and rinse frequently for your storage tanks if you're utilizing an acid detergent. The advantage, in addition to time saved on your overall cleaning cycle, is you don't have to purge your CO2. If you do run an alkaline or a caustic wash in your storage tank, first part of your procedure must be to purge your CO2. Just as if you mix an acid and a caustic, we all know that's bad news. Mixing a liquid caustic with the CO2 inside the storage tank will also create problems for you. The CO2 reacts with the alkalinity and neutralizes it, at the same time creating a vacuum because it goes from being a gas to being in the liquid. And you can crinkle the tanks, in particular if they're unvented or the vent isn't large enough. Can be a fairly violent reaction. So purge your CO2 if you do have to use an alkaline cleaner in the storage tank. And then even if you're just using acid detergent, rinse afterwards, followed by your sanitizing step. Fittings, hoses, etc. whatever happened to be in the tank is probably in the fittings, hoses, and so forth. So we need to get all that soil removed, and then we need to take care of our microorganisms. We're going to soak and manually clean these typically. Some can be cleaned as part of your CIP cycle, but you want to take those fittings apart. They're excellent places for both residual soil and residual cleaner, and they make great places for the microorganisms to set up housekeeping. So take them apart, manually clean them. Usually use a non-caustic cleaner here. Even though you're going to have gloved hands and you're going to be wearing an apron and your goggles, something that's easier to work with is always nice for your manual cleaning sink or tank. And then followed by sanitizing. Tank exteriors. We want to remove any residues of boil overs, splashes, so on and so forth. And we want to make them sparkle like new. Hard to CIP a tank exterior, hard to manually clean it. It's an excellent application for foam cleaning. Gives you good hang time for the cleaning, particularly on vertical surfaces where a spray cleaning will just run off. The foam will hang there 5 or 10 minutes. To make sure you get good distribution of your cleaner on the surface, you want to foam starting at the bottom of the tank and working your way toward the top. Opposite of that for rinsing it down, and you want to rinse before the foam dries. Rinse before the foam dries, and you want to rinse from the top toward the bottom. If it's a boil over or a spill, etc., you've got organic deposit on there, you want to use an alkaline foaming product. If it's inorganic, or to create or maintain the pristine, shiny look on the tank, you want to use an acid-based foaming product. And frequently you'll use the alkaline foamer, followed by a rinse, followed by the acid foaming for the sparkle. Floors and walls, very similar to tank exteriors. However, where on your vertical tank surface, everything's going to drip down. You're not going to get anything standing around wet and so on and so forth. Damp corners on the floors, hard to get to places. Excellent breeding ground for mold and mildew, and for yeast to grow as well. So take a special care to squeegee those areas as dry as you can get them if the floor is not quite right and doesn't naturally tilt toward the drain. You can also use your sanitizer on those surfaces as well to keep your mold and mildew down. Drains, sometimes stay clean depending on what all is going down the drain, where it's located, how often you use it, etc. Sometimes can be breeding ground for mold, mildew, yeast, etc. If you do have to do any manual cleaning on a drain, dedicate a brush to it. Don't use the same brush in a drain that you're going to use for your foam ring anywhere. So dedicate a brush to it, label it drain brush, set it aside in its special place. If you're spray cleaning your drain, trying to power down what you can above the trap, make sure not to splash a lot of water out of the drain, and spread the drain problems around in the rest of the brewery. A couple minutes on some special situations that we encounter in the brewery. Beer stone, which is calcium oxalate. Depending on the brew, it can form anywhere in the process. It can look like an off-white yellow. Typically, it's yellow or browner than ordinary inorganic scale, but it can look like just regular old calcium carbonate scale. The problem that you'll find is your standard caustic and your standard acid wash won't remove it. There are special cleaners and special additives that can be added into your alkaline cleaner if beer stone is a problem for you. And how do you know if it's a problem? Again, we're going to inspect our cleaning process, inspect our tanks before we start, and we're going to inspect the results afterwards. And if we've got deposit left over, make a determination of what that is. The other special situation I wanted to bring to your attention today was your silicate scales. If you're using supply water with high levels of silica, you can create a glassy silicate scale inside your tanks, again, anywhere that water goes. If you have a misapplication or a misuse of silica containing cleaners, you can create that glassy silica scale. It's typically a very clear scale, so you can look in your tank, you can look at your process and see right to the stainless steel, and sometimes not notice that you're starting to build up a clear, very hard silica-based scale. Where beer stone is a more frequent problem, beer stone's very easy to remove. Silica, infrequent problem, difficult to remove, but with the right acids in an acidic cleaner, you can take care of your silicate scales. So takeaways from today: remember, TACT wins. When you're doing your cleaning and you're thinking about things, think about your time, your action, your chemical, your temperature, the water, the individual doing the cleaning, the nature of the soil and the surface. And with those items properly understood, properly applied, you can be extremely successful in maintaining your brewery. We got a few minutes left. If anybody has any questions, I haven't seen anything in the comments section. So I hope that today's presentation was useful and informative for you. One of the items that I really like about the craft brewing industry is everyone's interaction. So if you've got questions, ask other brewers, ask other folks working in breweries, ask someone in your industry organization, whether that's CBP or your local guilds. Ask your chemical supplier. So what question came up. So what debris is organic and what debris is inorganic? So your organic debris are going to be anything that was once alive. So things left over from your malt, oil from your hops, those sorts of things. Your yeast, all of those are your organic deposits. Inorganics, typically going to be calcium carbonate. If you do have high iron staining, your mineral-based items are inorganic. Excellent. Good question. Well, I don't see anything else coming up here, guys and gals. So again, thank you very much for your time, and ask questions as they come up, and I wish you the best of success in your brewing endeavors.